Example 5 is going to be another repetition structure. It's going to be for the for loop. And almost done scrolling through this. The homework on this one, which is homework 5, that's the for loop homework, has kind of an overview of all of our structures. So all the homeworks have different type of videos that can be helpful. You'll see that some of the videos we have one on for loops, one on more for loops. Those are good. Those are going to teach you the basics of for loops. We're going to talk about the basics a little bit here, but those will be more in depth. But one of the most popular videos that I have is this if versus while versus for. And the whole video is nothing more than I have 3 different codes up. One showing if statements, one showing while loops, one showing for loops, and showing the similarities and differences between them. And I would recommend that if you're starting to feel really good about these, to really understand what the difference between those really are, so that you'll know how to design your own code. And if you're unsure, or if you just like to make sure you have a good understanding of it, that would be a good video to go ahead and watch. All right, so just a quick overview about for loops. We talked about loops in example 4. For loops are just another type of loop. It's another type of repetition structure. The difference with this one is a while loop usually is checking something like a sensor or something that we're unsure of how long the condition is going to be true for. A for loop, on the other hand, is when I want to repeat a chunk of code, this scope of code, but I know I want to repeat it for a certain number of times. And so if you know you want something to happen 10 different times, instead of having to copy and paste it 10 different times in a sequence, what you can do is you can put it once inside of the for loop and just tell the for loop to run 10 times. It's a little bit more difficult to do that. It's easier said than done for sure, because the condition of the for loop looks way more complex than a condition for an if statement or a while loop. But really, it is the same as for a while loop. It just has all the pieces in one line rather than spread throughout. I probably won't touch on it too much, if at all, during this example. We'll talk about it in class, but I do know that the videos on the for loop talk about while loops and how this is kind of an organized while loop. All right, so I do have a code already and circuit already set up. This one is relatively simple. Just to focus on the for loops, we're not dealing with any sensors, but I could use sensors for for loops if I wanted to. Code is very, very simple. I decided to put my test code just inside my void setup. Since I don't have any sensors or anything, I'm just going to turn on these LEDs, and that's about it, just making sure that everything's running well. So it all turns on. So that's good. I'm going to go ahead and stop the simulation, and we'll go ahead and clean this up a little bit. First things first, every single time we run things, I want to make my variables. I have LEDs, those are global variables, byte, LED R, I'm not sure, oh, I can see what pin that is, I don't have to scroll out. My red one is pin 3, and then byte, LED G, that one is going to be position 2. All right, so there we go. I'm also going to put a serial print in here because what I want to do, even though I don't have a sensor that is going to be, I need to check to see what's happening, I am going to have some variables in here that are changing that I want to make sure I know what's happening. And that'll make more sense once we have it in here. So just trust me for now. Let's make a serial.begin. All right, so there we go. A couple things really quick. If I have a variable, I'm going to make a global variable right now called byte x and I'm going to set that equal to 0. If inside the void loop, I write serial dot println and I print x, what's going to happen is over and over, it's going to print that 0. We'll go ahead and so it happens when I misspell things. There we go. All right. So I have this 0 and it's just printing over and over. That's kind of interesting, kind of boring, whatever. But what it is it's just showing what's happening. Now, there is a new piece of syntax, and we cover it in the videos, we'll cover it in class, but I'm going to talk about it here. If I type in x equals x plus 1, math class, this is horrible. It's like you can't do that. That's impossible. But you have to remember that this equal sign does not mean equals. In programming, it means a sign. So what it does is it takes our value of x, which the first time is 0. We add 1 to it. It gets a new value, right? It would be value of 1 would be on the right-hand side of the equal sign. And what we do is we assign that new value into x. So x is now going to equal 1. It's going to print that 1, and then it's going to come back up here to the loop. It's going to say, all right, let's take x. Remember, x now equals 1. We're going to add a 1 to it. So the right-hand side equals 2. We're going to save that 2 into x, and we're going to print that over and over. I'm going to put a delay in here so that we can see it happening a little bit. And it's just counting up. All right, so that's kind of interesting. We're going to use a little bit of this later. That's why we're talking about it, but I can simplify this. This x equals x plus 1 could be written as x plus plus. What that does is it adds 1 to whatever variable I write in front of it. In this case, the variable would be x. I'm going to go ahead and clear this. And let's go ahead and run it. Remember, the very first time through this, x equals 0. I went ahead and stopped it real quick because I wanted to look at this. I don't see the 0 anywhere. So the first question is, why don't I see the 0? And the reason why I don't see the 0 is because if we look at our code, the very first thing I do is I tell it to add 1 to it, and then I print. If I just change the order of these really quick, what it's going to do is it's first going to print, and then it's going to add 1 to it. So this next time through, it should print the 0 first. So that's just a little bit of overview, just kind of getting familiar with really understanding how things work and how the order really does matter of what's happening. All right, so that's one thing. The next thing we want to look at is if I take this delay, I'm going to reduce it. Remember that x is a byte, right? It's a byte type. And I've told you this before, that a byte holds a value between 0 and 255. I'm going to start the simulation and let's see what happens. It's going to count up a lot faster now. 60, 70, hundreds, 200, 230, and it started over. Do that one more time. I know it's moving quick. We can scroll back through it. So if I go back up here, here we go. We have 238, keeps counting up, counting up, counting up. We get to 255, and then it goes back down to 0. There's no spot in this code where I say start back over at 0. What's happening is because the spot in memory is a byte type, it can't hold a number bigger than 255, which means if I try to add 1 to it, it has to start back over. It can't hold anything larger than that. That's an important thing at some point, especially if your program's not quite running right. Data types are important, and this is one reason why. All right, we haven't talked about for loops yet at all. That's about ready to change. All right, so I'm actually going to say, let's write a while loop. I like to start with something that we've already done before. So if I have a while loop, and if I want this to happen while x is less than 10, something along these lines, I'm actually going to bring this x and byte back down here real quick. Remember, so I need a few things with the while loop. I need the word while with a condition and a scope. I need a way to get in. I have that on line 16. All right, I set a condition for my x variable, which I'm using in my condition, and I need a way out. I'm going to do that by taking everything except for the data type. And I'm going to paste it in here, but that's not going to do anything. If you think about it, it's like, wait a second, that's just saying x is going to equal to 0. So what I'm going to do this time, instead of copying and pasting it, I'm going to think about how do I want to change x? How is x going to change while this runs? If inside this while loop, I say, let's take x and let's add 1 to it every single time. What's going to happen is this while loop is going to run 10 times. And we can think of that, and sometimes I like to get a piece of paper out to really kind of work this out. X equals 0, which means this while loop is true, and so it runs once. While it's in there, x becomes 1. So it's going to come back up here and it's going to say, is x less than 10? Well, x equals 1. So yes, it's true. It's going to run again. So now it's ran twice, and it's going to update our x variable. Now x equals 2, x equals 3. And it's going to keep doing that over and over and over again until we get to 9. Is 9 less than 10? Yes, it is. We're going to come back down here. It's going to add 1 to it. Now x equals 10. Is x less than 10? No, it's not. That means that this while loop is now false. It's going to hop down here and do whatever else it needs to do. For now, I'm going to just put a delay of, let's say, a whole second in here. Now to see what's happening inside of here, I'm going to put our serial.println. I'm going to print x to see what's happening. We're going to add 1 to our x, and I'm just going to put a short delay in here just so that we can have time to see what's happening. All right, I'm going to run this really quick, and we'll see what happens. Remember, first time through the loop, x equals 0. This while loop should run 10 times. We're going to print out each time what x equals as it runs. X increases by 1 every time with a short delay. And when we're done, we'll hop out here. We'll have a longer delay. And we should hop back up here, x equaling 0, and we should start over again. Let's see if that's what happens. It would help if we didn't have errors. There we go. And so we'll see that it counts from 0 up to 9 and then pauses, and then it does it again. This is a while loop. We still haven't talked about for loops, but this is the idea of a for loop. I know I want this to run 10 times. And if I want it to run 10 times, then I can set up a while loop to run 10 times. I have to give it a starting number. I have to have it conditioned so that as I increase that number, I'm in there a certain number of times, and then I need to change that number somehow. But you can see I have everything spread out. I have my starting value here. I have my condition here, and I have how it changes right here. This is how a for loop works, except for we take all 3 of those pieces and we put them all on the same line. So first things first, I'm going to take this word while and I'm going to change it to for. I'm going to take this entire line, byte x equals 0, and I'm going to pull it into the parentheses, and it's going to be in front of the condition. I'm putting a space there just to make it easier to read. I'm then going to take how it changes, which is inside of my while loop or my old while loop, and I'm going to put that after my condition. And I could just delete this semicolon and put a new one here. I'm just going to move it over. I divide up those three things with semicolons. I need my starting value. I need the condition to check, and I need to know how that variable is going to change. If I put all those things, which are kind of spread out throughout my code, if I put them all on one line, it becomes a for loop. This should run exactly the same as before, but now it's all more compact instead of it being spread out. All right, so now I have a for loop that runs 10 times. And we've talked a little bit about how that for loop works. Now let's get to the actual example. The example is set up at least 2 LEDs, green and red. I don't remember if those are the colors I set up or not. Write a code where the red LED blinks 5 times and the green LED is off. This is the for loop. All right, so before I read the entire thing, I'm just going to go do that piece because I think I can do that piece. I do have red and green, and I can figure out how to blink this red one. It says do that inside the for loop. So inside the for loop, I'm going to just write the code that we worked on day 1, where we blinked an LED. Digital, right, LED R, high, delay, we'll do half a second. I don't think I specified. And then we're going to turn it off. Low. All right, so this is nothing more than our normal blinking code. But because it's in a for loop, it's going to happen however many times the for loop runs. So if I just start this right now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it stops for a second, and then it starts over. That long pause is when the for loop ended, and we come back down here. Now, without this second delay, then we couldn't see anything else happening, because if nothing else is happening, it's just going to come back up here and we're going to go through the for loop one more time. So without the delay, it's just going to blink all day. We can see that in memory, those numbers actually go from 0 to 9, and it is going to start back over, but we don't get any type of delay. We don't get any type of visual break. That's what's happening. It just looks like it's blinking infinitely. All right, we said that we wanted to blink 5 times. So I need to change something in the condition so that it blinks 5 times. I don't want it to run 10 times. I want it to run 5 times. I'm going to do that by changing the condition. Remember, the condition's the middle part. X is now going to, it's going to run while X is less than 5. If we start off at 0 each time, then this is how we would write it. I'll clear this. We'll see that our numbers now go from 0 to 4. That's 5 blinks. 1, 2, 3, 4, 5, and then it starts over. All right, so we have that first part completed now. It doesn't look like it's completed because now it does look like it's blinking forever, but we have a code where the red LED blinks 5 times and the green LED is off. And this is going to be, we're going to use a for loop for that. We did that. All right, then while the red LED is not blinking, the green LED will turn on. We're going to do that for 1 second. It's not going to blink. Just going to turn on once and then turn back off. It'll look like it blinks. It's like a one-time blink, turns on, and then turns off. Now I said do that while the red is not blinking. This for loop is the thing that's blinking the red LED. So if I want to turn the green one on when the red one is not blinking, red LED isn't blinking here. This is the red LED is blinking. So this for loop is the red LED is blinking, runs 5 times. Below here, we're out of the for loop. I can put the code down here for when the red LED isn't blinking. We're going to turn on the green one. We're going to wait, and then we're going to turn it off. Digital, right, LED G, high. All right, then we're going to delay. I said delay for 1 second. We're going to turn it off. And then we're done. I didn't say blink it, so there doesn't need to be a off for 1,000 milliseconds or for 1 second. While the red one's blinking, the green one's off. While the red one is not blinking, we turn the green one on for 1 second, and then we turn it off and we start over again. So let's go ahead and clear this off, and let's see what happens. 1, 2, 3, 4, 5, green. 1, 2, 3, 4, 5, green. So there we go. If I wanted to add a couple things in here, I could. I could take away this X, and instead of having it print X, what I could do is I could have it blink or print the word red. And when it's down here, I could have it print the word green. So let's go ahead and put that in right here. All right, so let's start the simulation really quick. Red, 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 green. So what I should get is I should get 5 reds printing and then a green. And that's what we have. So the idea of a for loop is if I know how many times I want to repeat something, we use a for loop. If I'm unsure how many times I need something to run, but I know I want it to repeat at some point, I can use a while loop. And so coming back to our repetition structure here, I can repeat something. If I'm unsure, I could use a sensor or something, and I could check that value, and it will run as many times as it needs to, as long as that condition's true. When it's no longer true, we leave. Or if I know I need something to run a specific number of times, I can write a code for that, and it will run this 5 times, and then it will leave. And so we have to figure out which one we want. For now, I think most people prefer while loops. After probably you get really comfortable with some code, you write a couple more codes, you're going to get much more comfortable, and you're going to prefer for loops for a lot of instances if you continue on with coding. But both are important. And remember, if you want something just to run once, we use a selection structure, which would be our if statement.